Okay, example number 4. Determine trigonometric ratios of quadrantal angles. Alright, so we're going to need to know what those are. So we're on the right. Quadrantal angle is an angle in standard position whose terminal arm lies on one of the axes. Examples are 0 degrees, 90 degrees, 180 degrees, 270 degrees, and 360. So if you recall from earlier diagrams, here is 0, 90, 180, 270, and 360. And there's actually more of them because if I keep rotating around the circle, I can just go 360 plus 90 and get another one over here, and then add another 90 and get another one here, and add another 90, get one here, another 90 and get one here, and so forth. Just keep going around the circle. Okay, so there's an infinite number of them. Okay, so we are going to determine the values of sine theta, cos theta, and tan theta where the terminal arm of quadrantal angle theta coincides with the positive y-axis, and that's where theta equals 90 degrees. Now we have to approach this differently than our last couple of examples because we won't be able to draw ourselves a reference triangle. Okay, so the first thing we're going to do is we're going to let the point P, X, Y be any point on the positive y-axis. Okay, so what that means then is that X is going to equal 0 because any point on the y-axis has a coordinate of x, which is 0. And we will also find that r is equal to y. Okay, so let's draw ourselves a picture to see why that is true. Okay, so in standard position, 90 degrees looks like this. Okay, and our point P, because it's on the y-axis, has an x-coordinate which is 0 and a y-coordinate which we will just leave as y. Now, we can't draw ourselves a reference angle for the reference triangle for this. What we can do though is we can consider a point moving around a circle. Okay? And so it would look something like this. Okay, so this point here will move counterclockwise around a circle. Okay? And so we can see that from the origin to our point is r, and that would be true over here too. Okay, and because we're considering our point being on the y-axis, we can also see that not only is the distance from the origin to our point r, the distance from the origin to our point is also y. Okay, and so we can see that r is equal to y. Alright, so the third thing that we want to do then is to determine what our trig ratios are. Okay, we know that x is equal to 0, y is just y, and we know that r is equal to y. So let's take a look. We want sine of 90 degrees, and our little formulas from earlier tell us that sine of 90 degrees will be y over r. And so sine of 90 degrees is equal to, well, we're going to keep y as is, but our radius is now y. And so we can see that sine of 90 degrees is y over y, and y over y is equal to 1. Okay, so now cos of 90 degrees. We know that that is x over r. And we know that x on the y-axis is 0, so 0 over. We know that r is y, So we'll put 0 over y. And the cos of 90 degrees then is 0 over y, which is 0. Okay, tan of 90 degrees is y over x. Okay, so tan of 90 degrees, well, y stays as y, but x is equal to 0, so tan of 90 degrees then is y over 0, which you know is undefined. Okay, so these are your trig ratios for 90 degrees. Sine of 90 is 1, cos of 90 is 0, tan of 90 is undefined. So that will end example 4.